In question 4, our scenario is that we have a repair company and they make service calls to people's homes. And 5% of the time, they go to the customer's house and nothing is wrong. 5% of the time, the issue is just due to customer error, like they forgot to turn something on or something's unplugged or whatever. So 5% of the time on service calls, it's just due to customer error. And so we're going to take 2 random service calls and see whether or not the problem is due to customer error. And so we want to find the probability that in this sample of 2 calls, 2 service trips, both problems are due to customer error. So we want to find the probability that on the first call, the problem is due to customer error, and the probability that on the second call, the problem is due to customer error. Now let's assume, we can assume that these 2 calls are independent, right? It's 2 totally different customers, they're not related. So we can assume these 2 service calls are independent. And so then this is equal to, if 2 events are independent, the probability of their intersection is just equal to the probability of the first event times the probability of the second event. And well, on any service call, the probability that it's due to customer error is 5%. So this is 0.05 times 0.05. And that is equal to 0.0025. So the probability that, given a sample of any 2 random service calls, the probability that both of them are just due to customer error is very small, 0.0025. Now let's find what's the probability that in any 2 service calls, at least one problem is not due to customer error. This is a little more complicated. So let's write out what we call a probability tree. In other words, we'll write out all possible outcomes. So on the first call, so let's say this is call 1. Call 1 can either be due to customer error or no customer error, right? And the probability that a call is due to customer error is just 0.05. And the probability that it's not due to customer error is 1 minus that 0.95. Okay, so now let's think about call 2. Again, call 2 can either be due to customer error or no error. Error or no error. You notice that I am branching off the first call. I am branching off either outcome for the first call. Again, this probability. I'll write these events here on the side. This is 0.05, 0.95, 0.05, 0.95. So the way to read this is that the probability that the first call was due to error and the second call was due to error is 0.05 times 0.05. This branch here is the probability that the first call was due to error and the second call was due to no error. This branch of the tree is if the first call is due to no error, second call is, and so on. So basically I've drawn out all the possible outcomes for the 2 calls. Okay, so let's go back to our problem. We want to find the probability that at least one call is not due to customer error. So at least one is no error. So that happens when the first call is due to no error and the second one is, or when the first call is no error and the second one is. That's at least one of the 2. That also happens when the first call is due to error and the second one is not. In all 3 of these scenarios, at least one of the calls is not due to customer error. Okay, so to calculate the probability of this event, all I do is add up the probability of each of these 3 branches. So let's do the pink branch. That's 0.05 times 0.95 plus, let's do the green branch, 0.95 times 0.05 plus the blue branch, 0.95 times 0.95. So in other words, the probability that at least one problem is not due to customer error is equal to the probability that the first call was due to error and the second one was not, plus the probability where this first call was no error but the second one was, plus the probability that both calls had no error. So let me just add all those up. I do 0.05 times 0.95. Okay, let's plug this into my calculator. Plus 0.95 times 0.95. If you do this, you should get 0.9975. And that's it.